All right. So good news. That good news is this is the last topic I was planning on covering before the final. Yep. So I think once we finish this, we'll just kind of go back and maybe reteach some things we're still a little fuzzy on and circle back to some things. But I think this is the last topic that I want to make sure that I get through inside of the first semester. Yes, Brian? No, I would plan on having a test on this. I think should have plenty of time to do all of that. But I just want to let you know that we should have good time to kind of circle back and touch on things that we had seen previously that we didn't feel great about. Still to go back and look at some of those things, okay? So this 2 sections is about the law of sines and the law of cosines. And hopefully you remember this kind of a problem that you saw with Wisconsin. So you should remember some problems that looked a little like this, where you're asked to solve the triangle, and you're given a right triangle that included, actually that's more information than you need. I'm getting rid of the 3. That included either a side length and an angle measure, or 2 side lengths. Or you could have had something like this, like that doesn't make a lot of sense there, dummy. Try that way. Let's make the long side the big number. Does anybody remember how we went about, when we say solve, what do we mean by solve? Yeah, it means find all the other unknown sides and all the unknown angles for that triangle. So let's just, for the sake of argument, let's give this triangle some name to it, some label. So I'm just going to call these triangles, I guess probably, just put some primes on it. So if we talk about this first triangle, ABC, that's not what I wanted to do. How do I turn this from drawing with my finger? Who uses this thing? Oh, okay. That's what I need. Good. All right. Okay. Thank you. So if I want to find this angle A in this situation, how can I do that? Good. Yeah, so you can use the triangle sum theorem from geometry that says the total degrees in a triangle is 180 degrees. So I can say the measure of angle A is 180 minus 90 minus 35. Or you could have just said there's a corollary to the triangle sum theorem for right triangles, which is what we're working with, where you can just do 90 minus the acute angle. Either way of doing it doesn't matter because you get the same answer. You get 55 degrees. Everybody happy with that? Let's say this side that's opposite angle A, typically we're going to name those lowercase letter a. How would I find that side little a? Now come now, computer. So I'm going to look at what I know. So what I know is either angle C or angle A. And then I know this side length. So let's pick one of angle A or angle C to work with. Let's just say, for the sake of argument, we pick angle A. It doesn't matter which one you choose. Good. Relative to angle A, this is opposite. What we want to know, and what we do know, is adjacent. So because we're in a right triangle, I can use tangent of 55 equals A over 4. So if I treat this as a proportion and cross multiply, I get A is equal to 4 times tangent of 55. And when I type that into my calculator, what mode would I want to make sure my calculator's in? Degree mode. And when I type in 4 times the tangent of 55, I get about 5.71. Now let's worry about this other side, because this other side is opposite of the angle B. I'm going to name it lowercase b. How can I find that side B? I could use the Pythagorean theorem since I have a right triangle and I know 3 sides of it. That's perfectly reasonable. Let's go ahead and do that then. So I can say that the hypotenuse squared is equal to the legs, the sum of the legs squared. And when I take the square root of that and type that into my calculator, I get about 6.97.
Here, Chico.
Okay, Jack, they need you urgently. That's a bummer. All right. We all kind of remember doing this. Okay. So here is the big question then. What if we don't have a right triangle? Well, we can't use SOHCAHTOA. What can we use? So we can use something called the law of sines. The law of sines states that sine of A over A is equal to sine of angle B over B equals sine of angle C over C. And that's for, in geometry? Yes, you did. Oh, you might have seen that. And again, for A, B, and C, what do we mean by capital A, capital B, capital C? Oops. We mean the angles and sides of any triangle. So again, worth noting there that that's not necessarily a right triangle. Or we could use the law of cosines. The law of cosine says that a squared is equal to b squared plus c squared minus 2bc cosine of a. Or you could say b squared equals a squared plus c squared minus 2ac cosine of b. Or you could say c squared equals a squared plus b squared minus 2ab cosine of angle C. These are all kind of equivalent statements. And again, what do these A, B, and C's mean? For just any old triangle, ABC. Did you get caught?
No. But it's about that.
Oh. So we have these two new rules that we can use to deal with non-right triangles. The big question is, now, when, let's say, how do I pick which one to use? Well, who remembers geometry? Do you remember your triangle similarity and congruence theorems? We used 3 letters to abbreviate them. We said things like side, 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 or side angle, side, and yeah. You guys kind of remember these? These situations are going to determine which one of the two formulas we want to use. That's not one of them. Nope. There is no angle side side theorem. Hi. This guy is in B11. So the law of cosines you're going to use if you have a side 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 situation or a side angle side situation. The law of sine situation you're going to use if you have an angle angle side or an angle side angle, and then I'm going to write in special color also if you have an SSA situation, but here we have to be very careful in this situation. Why do we have to be very careful here? As we were just pointed out, there is no side-side angle congruence theorem from geometry. So this particular situation, we can end up with multiple sets of answers. And we'll explain later when we get there kind of how to predict how many sets of answers would make a real triangle in that situation. And it gets to be a little bit tricky, but it's not horrible. But let's go to one of these less ambiguous situations. Okay. Are we ready to try one of these example problems here? Okay, we probably have enough time to do one of them. So let's say we want to solve this triangle. So if I want to do that, which one of these 5 situations have I landed in? Well, I have a side, I have an angle, and I have a side. They're all adjacent to each other. So this is the side angle side situation, which tells me I should be using the law of cosines. Everybody agree with that? So sure, let's talk about that right now. Okay? So, notice in the formula, well, what I'm going to find first with the law of cosines is this side here. What letter would I name this side? It's opposite angle B, so we would call this lowercase b. So which of my law of cosines formulas am I going to use then? B squared equals A squared plus C squared minus 2AC cosine of B. Gabby, is that okay? So what is my value for A? Who said 15? You are correct. Why is it 15? Because if I look at angle A, the side opposite that is 15. What's my value for C? 10. Because if I look at angle C, the side opposite that is 10. And my value for angle B is 105. Everybody happy with that? So, now all I do is I type this into my calculator. What mode do I need to be in? Still degree mode, right? How did I know degree mode? Because my angle measure was given to me in degrees. So when I add those things together in my calculator, I get 402.64, yada, 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 yada. Everybody's okay there? But what does that solve for? Is the mode in degrees? $12 squared instead of 15? That would do it. So, yes. So you are correct, whoever said the problem is that I have B squared. I need B. So when I take the square root of that, I get about 20.06. Actually, let's say 0.7, rounding up. Everybody okay with what I've done there? So I know that this side is 20.07. Okay, now how am I going to find either angle A or angle C? Well, if you'll notice now, for example, if I'm wanting to find angle A, I could say that I have a side angle side situation and use the law of cosines again. Or I could say, for example, I have an angle side I have an angle side angle situation and use the law of cosines. Law of sines. So it doesn't matter at this step. Once you've done that first law, you should be able to use either of the two. It should not matter. I'm going to choose to use the law of sines because I think it makes life a little bit easier because the formula is considerably less complicated. So what I'm going to say for the law of sines is I can say sine of angle A over, what side is opposite angle A? 15 equals, now what other angle do I have to use here? Can I use angle C? No, why not? I don't know what it is. Can only have one variable in my equation, so I certainly don't want to use angle C. I should use angle B. And then the side opposite angle B is 20.07. Is everybody okay with how I wrote my equation? So now I just need to solve for A. So I will cross multiply. That gives me 20.07 times sine of A equals 15 times sine of 105. And if you wanted to at this point, you could multiply 15 and 105 together and make a decimal. I'm going to choose not to because it just is more writing as far as I'm concerned. But if you're more comfortable with that, feel free to do that. To get the sine A by itself, what should I do? Well, I need to get rid of this here. So let's divide that away. So I have sine A equals 15 times sine 105 divided by 20.07. And again, if you want to turn that into a decimal, if you're more comfortable with that, you're welcome to do so. I'm going to leave it the way it is because it just seems like less writing to just kind of keep it there. But I want to get angle A. So how do I get the angle A by itself? How do I get rid of the sine in front of it? I use the inverse. So if I type that into my calculator, I get about 46.2 degrees. Now I still have one more thing to find. What do I need to find? If I go back to my original problem here, I still don't know angle C. How can I find that though? Yeah, I know that it's just using the triangle sum theorem. So I know the measure of angle C is going to equal 180 minus the measure of angle B minus the measure of angle A. So I get 28.8. Huh? Again, you'll get good at them. They're not that bad.